Section 4.3, dividing polynomials. There's two different ways that we can divide polynomials. The first way that I'm going to show you, polynomial long division, that works every time. Whether it doesn't really matter what we're dividing, polynomial long division will be successful every time. Polynomial long division is similar to regular long division. So if I said something like 1,264 divided by 12. Okay, we can think about, okay, 12 doesn't go into 1, but it does go into 12 one time, so we'll put a 1 there, and then we multiply 12 times 1 to get 12, and we subtract, and we get 0. Bring down the next number, that'd be 6. 12 goes into 6 0 times, so it'd be 0 there. And then we bring down the 4. How many times does 12 go into 64? That would be 5. Okay, so 12 times 5 is 60. And then we'd have 4 left over, so then we could have 105 with a remainder of 4. Okay, same idea is going to happen with polynomials. We're just going to do the same thing. Whoops, that was supposed to be the pointer. We're going to do the same thing here, but with polynomials. So, just as a reminder, where things go, the divisor goes on the outside of our cage. The dividend, whoops, let's spell that right. Dividend goes on the inside, and then the answer up top is called the quotient. Okay, so divisor, dividend, quotient, and then when we write it out, if you're writing it like this one down here, number 1, the divisor is actually second. So it's dividend divided by the divisor equals the quotient. Okay, I'm just going to leave it as quotient. Okay, so number 1, divide x cubed minus x squared minus 2x plus 8 divided by x minus 1. So the divisor, x minus 1, goes on the outside, x minus 1. The dividend goes on the inside. I'll do that in red. So we'll have x cubed minus x squared minus 2x plus 8. Now, first thing we're going to do, we're going to look at the biggest term in the inside and divide it by the biggest term on the outside, okay? So we're going to take x cubed divided by x squared, not x squared, sorry, that's just going to be x. X is on the outside. X cubed divided by x is x squared, and that answer goes above x squared, okay? Just like 12 didn't go into 1, but it does go into 12, and we put it above the 12. We put it in that number, in that placeholder. Okay, so now what we're going to do is we're going to change colors here again. We're going to take x squared times x minus 1, okay? So take x squared times x minus 1, get rid of those circles, and we'll put it below. So x squared times x is x cubed. X squared times negative 1 is negative x squared. And now we're going to subtract, okay? So we'll subtract straight down. X cubed minus x cubed, well, that's gone, that's 0. Negative x squared minus negative x squared, that is also 0. So we're going to have 0 left down here. Bring down the next term, minus 2x. If you want to, you can bring down the plus 8 as well. Okay, so now here is our new dividend. Now, I didn't talk about this, but the degree of the remainder must be less than the divisor. Well, the degree of what was left after we did our subtracting is degree 1. Our highest exponent is 1. The degree of our divisor is also 1. That is not less. They are the same. This has to be less than this in order for us to be done. Also, how I remember it, if there's still space up here, we can keep going. Okay, and I'll show you what that looks like here in just a second. So we're going to do this again. Take the biggest term in our dividend, and we're going to divide it by the biggest term in our divisor. So we're going to take negative 2x, and we're going to divide it by x. And what that leaves us with is negative 2. Now, I'm going to put that negative 2 above the constant term because this does not have an x in it. Okay, so I'm going to put negative 2 here, and we're going to multiply negative 2 times x minus 1. I'll write that off to the side. Negative 2 times x minus 1. And what we're going to get then when we do that is negative 2x plus 2. Negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. And we're going to subtract again. Negative 2x minus negative 2x is 0. And then 8 minus 2 is 6. Now, this is degree 0. There's no x value. This is degree 1. Once I'm to this point where my dividend has smaller degree than my divisor, I am done dividing. Okay, this is my new remainder. Okay, this is my final remainder. Now, the question becomes, how do you write it? Okay, So your answer then is going to be x squared minus 2 plus 6 over x minus 1. So it's not going to be, up in this example, this would have been 105 remainder 4, or remember 4, this would be 105 and 4/12. That's really what that means. We're doing the same thing. It's kind of hard to get your head wrapped around 6 over x minus 1, but this is in fact how you write it. So x squared minus 2 plus 6 over x minus 1. That is going to be your remainder, and this right here in green is your final answer. Let's try another one. Okay, 2x to the fourth plus 3x cubed plus 5x minus 1 divided by x squared plus 3x plus 2. So your dividend is on the outside, so x squared plus 3x plus 2 divided, and we'll do the dividend on the inside. Now, what you're going to notice is there's no squared term. What I'm going to do here is I'm going to 2x to the fourth plus 3x cubed. I'm going to make a space for the x squared term. So 0x squared plus 5x minus 1. I'm going to extend this bracket a little farther. And we're going to do the same thing. Take the biggest term on the inside, divide it by the biggest term on the outside. So I'm going to have 2x to the fourth divided by x squared. And what that leaves me with is 2x squared. Okay, so that answer goes above the x squared. And that's another reason why I put this x squared term in, because then I have that space for it when I am writing my answer. So 2x squared. Now what I'm going to do is I'm going to take 2x squared and multiply it by everything on the outside. Okay, so 2x squared times x squared gives me 2x to the fourth. 2x squared times 3x is 6x cubed. And 2x squared times 2 is 2x squared. And now I'm going to subtract. 2x to the fourth minus 2x to the fourth is 0. 3x to the third minus 6x to the third is negative 3x to the third power. 0x squared minus 2x squared is negative 2x squared. And then I'm going to bring down my next term. So this will be plus 5x. Could I bring down the minus 1? Sure, but I don't really need to at this point. Okay, do it again. My dividend has a higher degree than my divisor, 3 and then 2, so I can keep going. So now I'm going to take my new biggest term, negative 3x cubed, and I'm going to divide it by the biggest term again, x squared. And what that leaves me with is negative 3x. So I'm going to put negative 3x right above the x term in my quotient. So I'm going to get rid of this because I'm going to need the room to write. So we'll multiply negative 3x times the divisor. So negative 3x times x squared is negative 3x cubed. Negative 3x times positive 3x is negative 9x squared. And negative 3x times 2 is negative 6x. And we will subtract. Negative 3x cubed minus 3x cubed is 0. And I just realized that I made a mistake. When I multiplied 2x squared times 2, that should be 4x squared. 4x squared. So I need to make this 4x squared. And then when I subtract, 0 minus 4 is negative 4x squared. So now I'm okay. So I'm back to this part. When I subtract these two, I am at 0. Negative 4 minus negative 9 is positive 5x squared. And then I move on to the next one. 5x minus negative 6x. 5 minus negative 6 is positive 11x. And then once I'm done subtracting, I can bring down my minus 1 at the end. Okay, so now degree here is 2, degree here is 2. I can keep going. Plus, I have space here. That's how I know I can keep going. If I still have space on the end of my dividing bracket, I can keep going. So take your biggest term here, divided by the biggest term there, 5x squared divided by x squared leaves me with, that would be just 5, positive 5. Okay, so now I'm going to multiply 5 by everything out here. 5 times x squared is 5x squared. 5 times 3x is 15x, and 5 times 2 is positive 10. One last time going to subtract. 5x squared minus 5x squared is 0. 11x minus 15x is negative 4x, and negative 1 minus 10 is negative 11. Now the degree here is 1, the degree here is 2. I am finally smaller here than up in here. Okay, so I'm good to go to write my final answer. So my final answer is going to be, I'm going to have 2x squared, and then I have minus 3x, and then I have positive 5. Then my remainder plus negative 4x minus 11 over what I originally divided by, x squared plus 3x plus 2. This is your answer for example number 2. It's a mess. It's a long answer. But if you can follow these steps, it's not that difficult to get to. Just make sure you multiply correctly like I didn't do right up in here. Let's try another one. X to the fourth plus 2x squared minus x plus 5 divided by x squared minus x plus 1. What I'm going to do for the sake of saving time, I'm going to get the problem set up. This will go on the outside, x squared minus x plus 1. We're going to divide here. This will be on the inside, x to the fourth plus, I don't have an x cubed term, so I'm going to put 0x to the third plus 2x squared minus x plus 5. For the sake of saving time, I'm not going to go through all of these steps for this one, but what I will tell you, the answer here is x squared plus x plus 2 plus 3 over x squared minus x plus 1. That is your final answer. If you need help getting to that answer, please don't be afraid to ask. But for the sake of saving time, I'm going to skip the work on that one. But what I boxed in there in green is the correct answer. Okay, so that's polynomial long division. That way works every time, no matter what you're dividing with polynomials. You can do polynomial long division. There is a way to shortcut it, but it's only in certain cases. Okay, and the method is called synthetic division. Okay, it only works when we're dividing by the quantity x minus k. Okay, so I've got the steps written down here below. Write the coefficients of the dividend in order of descending exponents. Make sure you include the zeros for any missing terms. And then your k value is written to the left. And I'll show you what that all means in just a second. Step number 2, bring down the leading coefficient. Multiply the leading coefficient by the k value. Write that answer under the second coefficient and add down. Again, that probably makes no sense to you. I'm going to show you what it looks like. I've got several examples here for you. Hopefully that will make sense here in a minute. And then step number 3, repeat the process until you're finished. The numbers along the bottom are the coefficients of the quotient, and then the last number is going to be your remainder. Okay, so, whoops, slide that up. All right, so let's do this. So, synthetic division, the coefficients of your dividend get written in order of in descending order. So my first coefficient is a 1, then my next coefficient is negative 3, then negative 7, and then 6. And what I'm going to do, I'm going to make a little L, and you're going to need 2 lines of writing. So this will be one line up here, leave a space for writing, and then make your L under that second line. Okay, the k value is the opposite of this number. Okay, so in this case it's positive 2. This is going out front. So this is how we set it up. So we write the coefficients of the dividend in order of descending exponents. We've done that. That's what we've got here in purple. The include zeros for any missing terms. We don't have any missing terms here. 3, 2, 1, 0. We don't have any gaps. And then the k value written to the left. So the k value is the opposite of the number in your divisor. So positive 2. Now, step number 2, bring down the leading coefficient, multiply it by the k value, and write that answer under the second coefficient. So I'm going to bring down my k value, or my leading coefficient. That's a 1. I'm going to multiply it by the k value. 1 times 2, that is obviously 2. So I'm going to put that here. And then I'm going to add straight down. So bring it down, multiply, put it under the next number. Add straight down. Negative 3 plus 2 is, whoops, let me go back to the pen. That is negative 1. Okay? Do it again, because now we're to step 3. Repeat the process until finished. So now we're going to take negative 1 times 2. And let me come up with a different color. How about brown? Negative 1 times 2 is negative 2. That goes under the second number, or the next number, and add straight down. Negative 7 plus negative 2 is, go back to the pen, that is negative 9. Okay? And then I've got one more step here. Let's go with yellow. I'm going to take negative 9 times 2. That is negative 18. And then I'm going to add straight down again. 6 plus negative 18, or 6 minus 18 is negative 12. So now I'm done dividing. What this tells me, so if this was x cubed, when I go down a line, what this is now going to be is x squared. Okay? This one here was x squared. When I go down a line, now it's going to be x. This was x. When I go down the line, now it's my constant term. This would be x to the 0. and then, as it says here in step 3, the last number is the remainder. So then my final answer is going to be 1x squared minus x minus 9 plus negative 12 over, what did I originally divide by? X minus 2. This is your answer. I'm not really sure who figured out how this works, but it does work every time, as long as you're dividing by something that looks like this. Okay? Put your coefficients up first. Keep going through your process. Okay? This last number is going to be your remainder, and then these are your coefficients of your quotient 1 degree less. So if this was x cubed, when it comes down, it's now x squared. This was x squared, so when it comes down, now it's x. This was x, when it comes down, now it's the constant term. If this was your constant term, when it comes down, it's now your remainder. Okay, let's try another one. 2x cubed minus x minus 7 divided by x plus 3. So the first step, we need to write the coefficients of the dividend in descending order. So we have x cubed as our first one, so that's going to be a 2. We do not have an x squared, so that needs to be a 0. The coefficient on x is negative 1, and then my constant term is negative 7. Go ahead and make your L. The k value in this case is negative 3. It's the opposite of this number right here. So negative 3 is going to go out front. Okay, so now we've got it set up. Now we can go ahead and work through our answer. So bring down your leading coefficient. That's a 2. Multiply it by your k value. 2 times negative 3 is negative 6. Add straight down. 0 plus negative 6 is negative 6. And now we can keep going. Take negative 6 times negative 3. That's positive 18. Add straight down. Negative 1 plus 18 is 17. And do it again. 17 times 3, negative 3, is negative 51. And then add straight down. Negative 7 plus negative 51 is negative 58. So we've got our answers. We've got our numbers along the bottom. Remember, this was x cubed. So now when we come down, it's now x squared. This was x squared. When we come down, now it's x. This was x, so when we come down, that's now our constant term. And our constant term originally, negative 7, when we bring it down, is now our remainder. So our final answer is going to be 2x squared minus 6x positive 17, and then plus negative 58 over what we originally divided by, x plus 3. So hopefully that makes a little bit of sense to you. It works very well, very fast when you're dividing by something that looks like this, x minus k. The problem is this synthetic division only works when you're dividing by something like this. So the first couple of examples where we were dividing by x squared plus 2x plus 1, this wouldn't work. Synthetic division would not work. But if you're dividing by x plus 3, synthetic division is going to work very well. And just as a side note, in the future, we're going to be doing a lot of this, where we put a number out here and we can do this, because this is actually going to help us do some factoring. You know how we factored quadratics, we can actually factor bigger or higher degree polynomials, and that's what we're going to get to in section 4.4, but that's another video. Okay, so let's move on. The last main idea in section 3 is the remainder theorem. The remainder theorem says if a polynomial f of x is divided by x minus k, then the remainder r is equal to f of k. So what this basically says is that if we were to divide something synthetically, so like what we did here, the last couple of examples, okay? What this is telling us is rather than having to divide, or rather than having to plug and chug like we did in section 1, where if I told you to evaluate this when x equals negative 4, what we can kind of think of this as, we could divide this by, this would be our k value, so this would be x plus 4. So what we're basically telling you is that if I evaluated this when at x equals negative 3, my answer is the remainder. So if I were to plug negative 3 in for these x's, what I would get is negative 58. Okay? So let me show you what this looks like. Okay, so we're going to do the synthetic division. So we're going to have 5, negative 1, 13, and 29. Okay? I'm going to make my L. Now, when you're given the x value, that's the number that goes out on the left. Okay, that's the difference between synthetic substitution and synthetic division. If they give you an x plus 3 or a binomial, then you need to do the opposite. But if it just gives you the x value, that's the number that goes out front. Okay, so now we're just going to do the same thing. We're going to have 5. 5 times negative 4 is negative 20. Negative 1 plus negative 20 is negative 21. Negative 21 times 4 is negative 84. positive 84. 13 plus 84 is 97. And then 97 times negative 4 is negative 388. And then add down one more time. 29 plus negative 388 is negative 359. So what the remainder theorem says is that if we were to divide 5x cubed minus x squared plus 13x plus 29, and we divided it by x plus 4, the remainder of this, negative 359, is the same thing as f of negative 4. So f of negative 4 is equal to negative 359. So if you could do it one of two ways. If you're given the x value, sure, you could plug it in. 5 times negative 4 cubed minus negative 4 squared plus 13 times negative 4 plus 29. You would get negative 359 in the end if you do it correctly. Okay, this is kind of a different way to think about substituting. Rather than having to do plug and chug every time, offering a different way to try something. Number 2, let's try another one. Evaluate g of x equals 5x to the 4th plus 2x cubed minus 20x minus 6 when x equals 2. So I'm going to start with my synthetic setup. So my biggest exponent is 4, so 5, then 3 is 2. I don't have x squared, so I need a 0. So I still need that space if I have a gap. Then I've got negative 20, and then negative 6. And then my x value, this was the number that goes out front, 2. If it gives you the x value, that's the number that goes out front. If it gives you what you're dividing by, like here, then it's the opposite. Okay? So we'll do the same thing. Bring down the 5, multiply. 5 times 2 is 10. That goes under the 2. 10 plus 2 is 12. 12 times 2 is 24. 24 plus 0 is still 24. 24 times 2 is 48. Negative 20 plus 48 is negative 28. And then, it's positive 28. And then positive 28 times 2 is 56. 56 plus negative 6 is 50. So what this tells me, is that g of, what value do we use? We use 2. G of 2 is equal to 50. If you want to double check it, go ahead and plug and chug. We have 5, our x value is 2, so 5 times 2 to the 4th plus 2 times 2 to the 3rd. Didn't have an x squared, so minus 20 times 2, and then minus 6. So 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 times 5, that's 80. 2 to the 3rd is 8, times 2 is 16. Negative 20 times 2 is negative 40. And then minus 6, if you do 80 minus 40, that's 40. Plus 16 minus 6, yeah, we get 56. Or not 56, 50, sorry. 50. Okay? So, same number, different way to do it. Okay, so keep in mind we're going to use synthetic division a lot. Just going to get more practice with synthetic substitution. On a quiz or a test, I'd probably just say evaluate when x equals whatever. So it would be your choice. You could either plug and chug or you could do synthetic substitution. Just wanted to show you a secondary way to try to evaluate something that maybe doesn't require using exponents like we did here in orange. Sometimes you can just multiply, add, multiply, add, multiply, add, multiply, add to get to the same answer. So just something to think about moving forward.